Hola, mi clase. We are covering 4.2. We're going to determine slope and y-intercept. So we've worked on how to find the slope of a line, right? We use our slope formula or we write our triangles. The newest thing is talking about the y-intercept. We've actually talked about it. We've looked at it. We've just never defined it. So today we're going to determine the slope and the y-intercept of a line. So in our key terms, you can see our equation is y equals mx plus b. That's the form of the equation we were just working on in 4.1 and on our worksheet that we did in class. So y is still our y, x is still our x. The new things to us is our m and our b. The m is actually nothing new. If you look down below where it says slope, it says m. Well, all we're doing is giving it a letter and they're having it be m. It's exactly the same formula that we used before in 3.2 and 3.3. It's just that we're giving it a defined letter now, and unfortunately it's not s, it's m, and I know that's confusing, but it just is what it is. This is the same thing as what we did yesterday when we were talking about, not yesterday in class, when we did our warm-up. Remember that slope showed up 7/2. So just the same thing. So the newest thing is our y-intercept or our b. Now we've had this, right, in our worksheet. We had plus something or minus something, but now we're giving it a defined term, which is b. It's the y-coordinate of a plane where a graph crosses the y-axis, and it's where 0, b. And so that's when we had like +2. We could see that it didn't cross at 0, 0, but it's wherever x is 0, that's where b is, and that's what we call our y-intercept, where the line crosses the y-axis. So then this equation has a name. It's called the slope-intercept form. That's because it gives us the slope, right? This is our slope, and this is our y-intercept, and we just shorten it to int. It's a linear equation, so it's still going to be a line, right? There's our root word, line, written in the form y equals mx plus b, where m is the slope and b is the y-intercept of the equation's graph. All right, let's work on using this and identifying it. So we're going to first start with a story problem, get the hardest one out of the way. So we needed to determine the rate of change. Remember, the rate of change is our slope. And then it's your initial value. So remember in 4.1, you guys kept telling me about how it's the initial value, it's the initial cost, it's the initial starting point, right? This is our y-intercept. It's that initial cost, that initial starting, right? The initial fee to get into the fair, the initial amount to go bowling, okay? It's our starting point. So it says a phone salesperson is paid minimum weekly salary and a commission for each phone sold, as shown in the table. And I know this table is a little small, but I'll make sure I write them down better so you can see them. So it says, confirm the relationship is linear and give the constant rate of change, the slope, and the initial value, b. So we need to first confirm that it's a constant rate of change and that, or the rate of change is constant. So we're going to check that the slope is the same every time. Okay. So we're going to do that subtraction, right? Change in income, change in phone sales. We need to check the change. So we're going to actually subtract from here to here, and we're going to subtract from here to here, and we're going to subtract from here to here. And then we're going to do the same thing. I'm going to subtract, subtract, and subtract. So this is 40 take away 30, which would get us 10. And this is 30 take away 20, which gets us 10. And this is 20 take away 10, which gets us 10. And then down below, and I know it's hard to read, but that's 930 and then 780. And so we would need to subtract 930 minus 780. So we get 0, and then we need to borrow, and then 13, 12, 11, 10, 9, 8, 7, 6, 5, and then 1. So this is 150. So the next one's 780 minus 630. So again, I'm going to do that right here. Oops, I'm at 780 first. 780 minus 630. So I'm finding this right here. This is the change in income. That's what I'm doing over here. Here's the first one. Here's the second one. I'm finding the change in the income. So 0, 8765, and then we get 1. So that's good. We got 150 again. And then the last one is 630 take away 480. I'll do that up here just because I don't want to run around a room here. Here we go. So 630 minus 480. So 0, borrow, 13 take away 8 was 5. We did that here. And then 5 take away 4 is 1. So we get 150 again. So we get 150. That's my change in my income. So 150 over my change in phone sales, which is 10. And then we reduce it, and we either can say it's 15 over 1, or we can just say it's 15. So what that means is he earns $15 for every one phone he sells. Right? That's his unit rate. He gets $15 for every one phone he sells. So now that we have that, that's his commission, right? That's how much he gets. We need to figure out what his initial value is. So even if the salesperson doesn't sell any phones, they still earn income. They get a weekly salary no matter what. So now what we need to do is figure out what is that weekly salary before the salesperson even sells any phones. So that's what it says here. It says find the initial value when the number of phones is 0. So that's what we're going to do. Okay. So I'm going to show you 2 different ways to find this initial value, which is our B, right? This was our slope, and now what we're trying to find is our B. So I'm going to show you 2 different ways. One way to do it is I'm going to take my equation, and I'm going to plug in everything I know. So I know that M is 15. I'm trying to find B. I actually do know some X and Y values. They're these right here. Remember, this was X and this is Y. So what I'm going to do is I'm going to take this first point. The point is 10, 480. This is my X. Oops. And this is my Y. And what I'm going to do is I'm going to plug it into this equation. And we're going to solve an equation. So my Y is 480. I'm going to set it equal to 15. Oops, that's a really bad 15. Let me fix that. 15. I'm going to times it by 10 because that's what X is. And then I'm going to just write plus B because that's the one thing I don't know. Right? I'm trying to solve for this. This is what I don't know. This is my question mark. So 15 times 10 would get me 150. We're going to go plus B. And then we leave the 480 because we didn't do anything with it. Now this is like solving a one-step equation. I want to get B by itself. So I'm going to do inverse operations. I'm going to subtract 150 from both sides. So we get 0. 8 take away 5 is 3. And then 4 take away 1 is 2. And that's it. We're done. That's what B is. There's our initial value. So this means that he makes $230 every week, no matter if he sells a phone or not. Okay, so that's 230. So that's one way you can do it, is plug in a point and solve. There's another way you can do it on your table, and it only works if it's gonna jump to so that you can get to 0. So notice these all jump by 10s. Well, 10 minus 10 gets me that 0 that I'm looking for, right? I want X to be 0. Well, since I can move all these by 10, I can then move this way by the 150, which, by the way, we did. 480 take away 150. And even that way gets me 230. So we'll practice that a little bit more on some tables, but 2 ways you can do it. This is the way I normally do it, but you can definitely do it this way. Sorry, I'm going to pause so I can answer my phone.
Don't make anyone watch Mr. Dance's video.
All right, so we figured out what our M was. and we figured out what our B was, and now that we know those things, we can write the equation. So our initial value was our B, it was this 230. And the sales receiver have a salary of that means the salesperson receives $230 each week before commissions. That's what that means. So an initial value of $230 means that the salesperson receives a salary of $230. I'll put the little mini dollar sign right here. Each week before commission. Okay. Now we have B, we have M. Here's our equation. So we're going to go Y. Y always just stays Y. We don't fill it in. Our M was 15, so I'm going to fill that in. I'm going to put X, because we never fill in X, and then we're going to go plus 230. Now look at that. It looks exactly like the equations from class and our notes and, oops, excuse the announcement.
Adriana Partega, please come to the office.
And so that looks exactly like the real world questions that we had in 4.1. All right, so we're now going to find the slope and the y-intercept of this line by this table. So we get to do this a little differently. We actually no, just not a story problem. So we're going to still find the difference. So from here to here is 2, and from here to here is 2. From here to here is 2, and then I'm going to subtract here, and 52 take away 42 is 10, and 42 take away 32 is 10, and 32 take away 22 is 10. So I'm going to take my rise over my run, and that's going to be 10 over 2, but we always have to reduce, so we get, that's a really bad 5. We get 5. Now, remember there's 2 ways to find our initial value or our y-intercept, aka our B. One way is I can pick a point, so maybe I choose this point here, and I plug it into my equation, y equals mx plus b. So I'm going to go 22 equals 5 times 2, right, plus b. So I get 22 equals 10 plus b, and then I minus 10 like a one-step equation, and we get b equals 12. And so that's our initial value, or our b. Now remember, the other way I can do it is continue this pattern as long as it can get me to 0. Well, if I subtract 2 here, I get 0. And if I subtract 10 here, I get 12. So remember, those are the 2 ways you can do it on the table. So now we have our M, we have our B. We're going to write the equation as y equals 5x plus 12. All right, so for our graph, it's a little different. We actually can find our y-intercept faster. It's wherever x is 0. It's wherever this blue line crosses the y-axis. So right there, and then that number right there is our b. So our y-intercept is 1. Done. So what's really nice about finding it on a graph is that it's sometimes right there on the graph. Now for the slope, we're going to make our triangle. So I'm going to count down 1, 2, 3, 4. And I went down, so it's a negative. And then I'm going to go 1, 2, and I went to the right, so it's positive. We have negative 4 over 2, and so we get negative 2. And then we just go y equals negative 2x plus 1. We're done. Graphs are my favorite. I think they're the easiest to find the equation for. All right, so things to remember is that it's y equals m, which is your slope, x plus b, and this is our y-intercept. Okay, so step 1, find slope. Step 2, find y-intercept. Step 3, plug into equation. Nope, that's a G. So remember we talked about in class as well that the slope didn't disappear, it just became something a little different, looked a little different, but it was always there, still next to our x. All right, so here's your independent practice. You need to find the slope and the y-intercept of the table and the graph, and then you need to write the equation for the table and the graph. Okay, if you need a help reminder, it's just like the last two right above that we just did together. All right, adios.